Hi everyone, hope you're all well and raring to go. So we're back to Unit 11, Learning Outcome 1. We've done P1 now, looking at 3D modelling techniques. We've got P2 still to go. The last section for Learning Outcome 1, looking at how 3D models are used for different media products, the different ways they're used in games versus how they're used in movies. So you've got in your workbook a section on characters in games and environments in games, and you've got a section on characters in movies and environments in movies. And this could be a 3D animation like Toy Story, or it could be a CG heavy film like Star Wars or Pacific Rim or something like that. So for each of these, I'd like to pick a case study. So pick a game and talk about how the characters are used in that game, and then pick a game and talk about how environments are used. Same thing for movies. And then for that case study, the structure I'd like you to use is discussing how they're used, what are the styles, what is the process, how are they optimized, what are the constraints, and then thinking about doing this as a separate section, talking more about the summarizing the challenges to 3D designers. So I'm going to talk about each one of these headings here in terms of how to structure your case study. So when it comes to how these are used, so thinking about what types of characters you have in a game or animation. So it could be in terms of the archetypes that you learned about in Unit 1, looking at Star Wars, heroes and villains and helpers and donors and all that kind of stuff. These exist in games and animation, so that would be the way to go. And you could also talk about NPCs, non-playable characters, and how they interact with the player. Types of environments, viewpoints. So in a game, we've got first-person viewpoints and third-person. Even in a first-person game, we will have elements of the character on display, whether it's a weapon or a body part or a prop. And then when it comes to world design, in an animation, the world is normally built more like a set. So in this example here, this Blender Foundation animation set in a barbershop, it's set inside the barbershop, so there was no requirement to build any exterior elements of the environment. It's all inside the barbershop on the ground level, and then I think bits of it set in the basement. And then think about different world level designs. So whether it's open world games like Red Dead Redemption, how is that utilized within the game versus Metroidvania or Dark Souls type games where all the levels and areas are interconnected and linked back to each other in interesting ways. When it comes to style, we're talking here about art style mainly rather than narrative style or gameplay style. It's the 3D assets, the 3D models that we're thinking about here. So when it comes to games, there are so many different art styles that I ran out of space on the slide. So from film noir in Limbo here to that kind of dark gothic style of games like Bloodborne, low poly mobile games like Lara Croft Go, that retro pixel art style of Minecraft that you guys are so familiar with, or the realistic cinematic style of games like Detroit Become Human or Heavy Rain or Call of Duty, or games like BioShock, who are borrowing directly from fine art movements like Art Deco, the painterly oil paint kind of aesthetic that's going on in Dishonored, or the illustrative, more kind of comic booky look of Borderlands. And so obviously this is quite video game heavy here. The same thing applies in animation. There are various different art styles on display, so you just need to discuss that and how it compares to other art styles in that genre. So in animation, we've got a kind of resurgence of more handmade lo-fi styles in films like Kubo and the Five Strings, where they combined stop motion with CG to get lots of really nice paper cut animation effects, to the sort of really hyper real Star Wars CG. It does pain me to include Jar Jar, but Why not? Um, then when it comes to the process, so you could be talking about retopology. I'm not going to talk too much about that right now. That's for you to go away and research. But it's this process of retopologizing a high poly model. So you might get a game designer who creates a really high res character that's not going to be efficient in a video game, and therefore that high res model needs to be retopologized. It needs to be remodeled with a low poly skin, and then the detail is transferred from the high poly model to the low poly model via the use of textures. So that I'd like you to research. What's the process when it comes to animating the hair or grass in animations using physics simulations? Combining 3D and 2D to create really interesting effects, such as in the animation Paperman. I will give links to all these kind of things as we come to them. Or just the use of textures or rigging. I should have added the use of rigging here, but just talking about the process in these kinds of terms. When it comes to optimization and the constraints, this is really about games versus animation. What is the main difference? The main constraint when it comes to video game design is polygon count. So this constant battle to give you the most beautiful graphics with the lowest number of polygons used. So there's various different techniques that are employed to give the effect of detail. So we talked about retopology, using bump maps and normal maps, displacement maps, to give the impression of detail that isn't actually there on the model. Texture painting, so applying 2D textures onto 3D models. Baking lighting information is a really good one, which we will look at. We'll be looking at most of these things actually as part of the course, but baking lighting information is a really good one. So this is a type of shadow known as ambient occlusion, and you can make an ambient occlusion bake by going through the process in your 3D software of applying the lighting information directly to a 2D texture, and then applying that 2D texture to your model so that the engine doesn't need to render that lighting information at all. It's all baked onto the texture. So for video games, it's all about that polygon count and what is the process that designers go through to make it look as nice as possible. Whereas with an animation, the only real constraint, they don't have to worry about polygon count at all. They can use as many polygons as they want. The only constraint they have is time, so how long it takes to render that stuff. Because, of course, with a video game, it's rendering real time. It's rendering on demand. When the player uses the controls, the character needs to respond there and then in real time. So this Blender animation here, this is the barbershop again, and this was taking, I think it took hundreds of hours to render a frame of animation, whereas something like Blighttown in Dark Souls, if you've ever found yourself there on a dark lonely night, you'll discover the problems with rendering real time, as you get some serious lag while the console or your computer tries to process all the assets in the scene, as well as the lighting information and the animations that are happening. So that's the difference. This is a good. These two images here are quite nice to consider, since they are both from the same period of time. So this is the first Toy Story film, and if you compare the, that's annoying. Go away. If you compare the resolution there with Tomb Raider, the first Tomb Raider game that came out around about the same time, it was about 1995, 1996. You can see the constraints illustrated quite clearly in these two images. Okay, so Toy Story had to be rendered once. It would have taken an awful long time, but you can imagine waiting 12 hours for each frame of your animation to render whilst playing a video game that's attempting to give you 60 frames per second. Yeah, so that's the deal. We'll provide you with resources so that you can research these topics here. And these are going to be very useful to know moving forward with the more practical parts of your coursework. When it comes to the challenges, glitches and bugs in video games, so we've got the Jarl here clipping through his chair, and the famous chap here who manages somehow to sleep whilst hovering in midair. And then, I'll be giving you a really good website from Pixar, which talks about the challenges that they face trying to create believable movement and realistic textures, and again, hair simulations using physics simulations. There's all sorts of really good resources out there on the challenges that the Pixar animators face when it comes to creating these wonderful animations. So I think that's about it. So I haven't gone into any detail whatsoever. I just didn't want you going in blind again. So we'll provide you with the resources, try and find as many good links as we can, but ultimately it's up to you to research these elements. You've got the workbook, and you've got Classroom for asking any questions. Please don't hesitate to post public questions on the stream. There's no such thing as a silly question. If you post it on the stream, then the answer could be helpful for everyone. Otherwise, just fire us an email or add private comments to your documents or whatever. But please keep in touch. Please ask questions, and I will hopefully be seeing you soon.